Hello, today we will present the Desoutter solutions for the smart factory, so the factory of the future. The target of today is to show you the different bricks of solutions we've got in terms of drilling, tightening, measurement and process control to achieve the requirement for the industry of the future. So this is the system. What we've got on this laptop, this is a software called CVI Fusion, where you will create and you will build the aerospace and your assembly sequence. Then we move to this part where we have the screen, which is basically the HMI, where the operator can follow the different sequence of the operations. The same operator can follow, if necessary, and pilot the full sequence with a mobile HMI that can be with the operator. So really useful when you go to large fuselage section. Or we could think as well about some potential projection solutions. Then we move to the tools. What we will show is how to sequence and how to pilot and control your process, including feature drilling with the EVO, with different heads, including temporary fasteners or drill jig fastening and clamping, as well as manual drilling with the prototype of Easy. We will see as well the different potential that we have for the tightening and how finally we can control the different measurement equipment that we've got. Okay, so let's start the process. First, by logging into the system. So I will log, obviously that can be done with a barcode reader. I will log as an operator. Okay. And then, as an operator, the only thing I need to do is follow the different sequence. So what I do, I scan the aircraft part number on my part. Okay. Then obviously with this process you can manage different variants of aircrafts. So let's imagine in the same station, in the same workshop, you've got different aircraft with different manufacturing layouts and processes to follow. Then you can manage the diversity of the different solutions. In that case, the aircraft that we selected and that we are working on is an A350-900. We will see that if we add an A350-1000, then the process will be different. So the operator will confirm directly on his HMI that he's got the right aircraft. Then we move and we need to select the drill jig. So if the operator, for example, has several digits available, then he will scan one of the drill jigs and then the system will lock and will block him when the drill jig selected is the right one. So if I select the right one, then I can move to the next step. So I've got the right drill jig. Okay. Then I will select the right temporary fastener, as indicated by my screen. So the top left, and I will scan the box to make sure I've got the right temporary fastener. Then we select the tool and the head as described by the screen. What we see here is that the tool requires the head to be plugged. So we've got on the head, we've got an RFID tag, which is going to be read by the tool, and the tool will select automatically and adjust the drilling or tightening sequence to adjust to the application. So I connect my head. So I follow the sequence, then I got the right speed and the right torque, which is linked to this temporary fastener application. And I follow the sequence. I start with this temporary fastener. Okay. And then if you follow what I've got on my screen, then you see already on the screen the green result, which means that tightening has been done correctly. And I move straight to the next step, which is another tightening on the temporary fastener. And as you can see, we moved directly to the next operation, which is drilling with the EVO head. So what I do is I connect my EVO, which is the machine, and then I will need to select my head. If I don't select the right head, then the process will not allow me to carry on in the process. So let's say I will connect my head. Then the system is reading with the RFID tag. I in the system. Okay, and then I can do my drilling. That's a fake drilling, obviously. cycle completed. So once I've got cycle completed, if my drilling has been done correctly, then I will move automatically to the next step. Okay, so as you can see on the screen, I need to change the head A to head B, which is, let's assume, this one. I connect my new head. I confirm that I've done my change. Then I've got the same system. My motor will read the head. I do the init. And then I can do my next drilling operation. Cycle completed, same ID. So what happens with the system, as you will see, we will move straight to the next operation, which is in the process, remove the temporary fastener head. So once again, I need to take my tool, take my head, connect my head. I see the screen, I push on the back button, and I will untighten my two temporary fasteners. Same thing. Now I can get rid of my drill jig and move to the next operation. As you've seen, now the system recognizes directly that we've done the operation correctly, so that will guide me to the next operation, which is drilling. So this is a real life process, so we would say we will enlarge the holes that were used for the drill jig. So same idea, I need to connect my head. So I take my head, and the system will not allow me to select a different head. If I look, for example, if I take the wrong head, which is rimming, then I try to connect, then I cannot start my machine. If I connect the right head, which is drilling, then I can connect the head. On this example, we've got, this is aluminum, so we get a speed which is set up at 3000 RPM. Okay, so we will do the drilling operation. This is fake again. Okay. Drilling has been done, as you see, on the first, and now we need to enlarge the second temporary fastener, the temporary fastener hole. So I'll do my second drilling, where I've got the yellow light blinking. Okay, and then I move, same process, I move to the reaming operation. So I select my second head, I connect, and as you see with the same tool, now we are reaming at a speed of 600 RPM. So the motor directly recognizes the head. So I'll do my reaming. Same thing, following the sequence. And as you see, there's a reporting. When the operation is done correctly, then you will have a green light directly on the surface. Okay. Then we can incorporate in this process control operation. This one is, for example, a manual control operation. So I haven't got the gauge right now with me. So in that case, for example, I need to connect as a supervisor. So we can manage as well accessibility rights. And I connect as a supervisor, and I can skip the step, which I cannot do when I'm only the operator. So I skip the step. Then I can incorporate as well different type of measurement. This one, it could be measuring the countersink depth or diameter. It could be Wi-Fi, or it could be manual entry. So for example, on this one I haven't got Wi-Fi, so I need to enter one value, which then I confirm will allow or not to move to the next operation. Okay, and then with that we can work with logic and sequence. Now we will move to the tightening phase. So on the tightening, I can consider that I've got serialized fasteners that can be really critical safety fasteners. So on this one, I took the options to select them by barcode reading. So this is what I will do. I pick up my fasteners, and then I will move to my tightening operations. So in the tightening operation, I will use an EAB com with quick release head. Same principle, we've got one tool and several heads, depending on the applications. So my system will automatically send me to the right crowfoot. So I will pick up the crowfoot which is blinking, and then my tool. I'll connect my tool, my head, and the tool will automatically recognize the fastener that needs to be, and the tightening parameters that needs to be launched. Okay, so I'll do my tightening. And here I've got a green. So the tightening has been done correctly, and you see directly the reporting. And then if the tightening has been done correctly, then and only then I can move to the next tightening operation. Okay, then we move to a different sequence, which is the picking. So with my system I can as well manage different type of picking using I/O, for example. So on this one I see the light, I need to go and pick the fastener which is in the box with the light. So I pick up my fastener, I install my fastener, okay, and again I will follow my instructions saying I need to pick up to do this tightening using the head which is blinking in my socket tray. Okay, so I install my head, sorry. Okay, and as you see the system will automatically recognize the fact that we've got a different tightening parameter. And then again I can do my tightening. And then again, I'm lucky. Same system. The next one is the light. Okay, now we'll move to the manual tightening on the drill for temporary fastener. So I will do that with my delta wrench. Then I've got a good tightening, and my system will automatically print the confirmation label, which I can, for example, and that's only an example, which I can print and stick on my part for traceability reason, and then move to the next step of the process. As you will see, you will get with the pivot software, then you will get a full traceability. I go for quick view, last cycle, short cycles. Then my system is linked to a database, and I can retrieve exactly the different information with, for each one of the steps of the process, the outcome, the time, and potentially the operator that has done it. So this is how we finalize and we close the loop with full traceability on each one of the steps of the operations. So that's some examples of the Industry 4.0 the smart factory with the Desoutter tools and process control.